Sauce here. This is a video lesson for Python programming, surfaces. I've started with the stub. The stub includes some basic graphic settings. I have imported a dictionary called palette from a file called palette. That's a dictionary of colors that I'll be using in this program. I can see on the left I have a window open with a folder that contains my code file and the resources, including that palette code file, that are being imported into my example program here. I have a frame loop, and before that I have a load resources comment, which is the typical place before the frame loop starts that we might load sounds and graphics that we would use. After that location, we're going to make another comment, title it Surfaces. This is the place in a code file right before the frame loop, and after we've loaded resources, which can include graphics, that would be the perfect place to create new surfaces. The primary screen is a surface in that it is a matrix of colored pixels. It's rectangular, and we can draw graphics to it to give a visual presentation in our program. Surfaces are additional matrices of colored pixels, and we can use additional graphic surfaces, graphic rectangles, in order to make our presentation of graphics more sophisticated and easier to program for more sophisticated effects. We create a surface. It's a rectangle of color with a function, which is a call to the class called surface, because a surface is an instance of class surface. So we capitalize the S in the name surface. In the argument, we must supply a tuple of 2, which will be the width and height of the new pixel matrix that we're creating. When we create a surface, we typically want to assign it to be the value of a variable. In this case, I'm going to use the variable surface_small. I start with the word surface to remind me that this variable stands for a color, a rectangle matrix of color, a surface that I can use for graphics. And it's going to be small because it's going to describe this surface, and it'll be distinguished from a couple of others. The next thing I'm going to do is I'm going to generalize this line of code with the variable surface underscore equal to pygame.surface, and then stub out the tuple of 2 and comment this out. This can now serve as a note, and I can copy and paste it in order to make surfaces. I'm going to copy and paste it twice. I'm going to create a surface called surface_medium and one called surface_large. The medium surface will have a width of 200 and a height of 200. The large, 400 by 400. They could be called rectangular matrices of colored pixels. If the dimensions are the same, technically their shape is square. Now, if I save and run, I don't see anything different. I might have created the surfaces without error, but we can't see them until we use them. And we wouldn't be able to see them if they're black and we put them on a black screen. So the next thing I'm going to do is I'm going to fill the surfaces that I've created with color. The screen, the primary screen, is a surface. We use it and do things to it. It is kind of special because the screen is the required primary surface that we put everything onto and then update for the user to see. But we fill surfaces just like we fill the primary screen with the command appended to the name of the surface. Surface underscore small dot fill, and then we'll need a color to put onto that surface, in this case red, from the dictionary palette. I'm going to copy this line of code because I'm going to fill the medium and large surface, but with different colors. The medium will be green and the large will be blue. Now that I have them filled, I can save and run and get the same thing, because even though I've filled them, I haven't used them. So what does it mean to use a surface? We can use graphic surfaces in many ways, but what we want is just to see the entire thing on the screen. So I'm going to go down to my frame loop where I create the screen that the user sees when I update it, and I'm going to blit my small surface to the screen. Blit is a term that means to combine the bit blocks one on another. Bit blocks are how this information is stored in memory. It's a function, and I use it by referring first to the surface that will receive the other. So the screen is going to be the surface that is blitted to. And then I use the function blit. The argument then includes the surface that will be blitted to the other, in this case surface underscore small, and then the location of the top left corner on the screen of the surface that I'm blitting. If I have the coordinate 1010, it means that the rectangular surface of screen will then have this other smaller surface put onto it visually. And the location of the small surface will be at 1010. That's 10 horizontal and 10 vertical from the top. The top left corner of the small surface will go at that location, and everything else will also be seen. Let's see what happens when we blit the small surface to the screen. We see that square of red color. It's not a rectangle that we drew on the screen. That is the entire surface whose size is 100 wide, 100 tall, filled with red that has been placed on the screen. And that placement we call blitting. The corner, the top left corner of that red surface is at the coordinate 1010 on the screen. That's 10 over and 10 from the top. Let's make a comment about that word blit. The word blit means to combine bit blocks, which is a term that comes from the language involved in how information is stored in a computer. We can think of it as combining blocks of information, as if the surfaces themselves are matrices of color information. They are in the computer's memory, but we see that color information as rows and columns of colored pixels. So blit means to combine blit blocks, put one on the other. Let's blit again. We're going to refer to screen, blit to it. In this case, we're going to blit the medium surface at the coordinate 50, 50. That means the top left corner of the medium surface, which we expect to be filled with the green color, is going to be located on the screen at the screen's coordinate 50, 50. Let's see what that looks like. we have still the small red surface and then the larger green surface. And we see a layering effect. That layering effect is important because the order in which we blit matters. We started with the screen and we filled it black. Then we blitted the small red surface. And then afterwards we blitted the green surface, which partially covered the red that existed. Order is important, and we can use the order in which we assemble different graphic components in order to control what we see for certain effects. Let's do something else. Let's do another blit, but it will not be the screen that will receive this blit. We're going to take the medium surface and we're going to blit to it the larger at the coordinate 50, 50. Let's see what happens. Now, I want to point out that the screen is filled with black at the beginning of this loop. We can see some red, some green, and some blue. Red is small, green is medium, and blue is large. We know that the order of this process is we fill the screen with black, then we put or blit the red one at the coordinate 10, 10, then we put the green one at the coordinate 50, 50. We've added this new line of code that put the large surface at the coordinate 50, 50 on the green one. Now this corner of blue is not at 50, 50 on the screen. Because we blitted the blue larger surface to the green one, then the upper left corner of the large blue surface is at the coordinate on the green surface, 50, 50. Now, something happened that we were unable to detect because of the speed of the computer. Remember, the order in which we blit is important. So the order was fill the screen black, draw the blue, draw the green, and then put the blue on the green. Why do we see the blue at all? Because we didn't blit the blue to the screen, and we blitted the green medium surface before we blitted the blue one. So why did the blue show up? And the reason is because we did that in the first frame that ran. We put the large blue surface onto the green one. And ever afterwards, even though we didn't see that effect the first time, in the second frame, that blue surface was already on the green. So when we blit the green surface, then the modification of seeing the blue was already there. So the order is really important. And if we were to start our frame each time by filling that medium surface with green, it's going to affect the outcome. We'll do that and show it. The surface, the medium surface, is going to get a fill. And we're going to fill it just as we did before, so we could copy this line. And run our code. The difference being is that every single frame we're going to start with the medium surface being filled with green, just like it was the first time. And now we don't see the blue because the blue is blitted to the green surface after we blit the green surface to the screen. We don't see the effect. Not in the order of how the frame is composed. Again, we saw the effect the first time because we failed to erase that effect. So the second frame, we saw the effect in the second frame, but not the first. Another thing to note, and we'll see now the medium surface's effect if we blit it afterwards. So we're changing the order. We're still erasing the medium surface by turning it all green at the beginning of every frame, but we're going to put the blue surface on first and then blit the medium surface to the screen. And we see now the blue. Another thing to note is the blue surface is larger than the green surface. The blue surface's dimensions are 400 by 400. It doesn't fit on the smaller 200 by 200 green surface. But what we get then is we see the portion that we're able to see by the size of the surface. We can't see the rest of the size of the blue surface because the blue large surface is not blitted to the screen. It first goes to the medium smaller surface, and the medium surface only receives as much of that as fits in that space. Then when we blit the medium surface, we see all of only the medium surface. Now we can see the entirety of the blue surface if we blitted it somewhere else. So we'll do that. We're going to blit the large at the location 200, 200 onto the screen. So we're seeing the large surface, and it also goes off the screen because it's large enough that it gets to the bottom and continues. And we see the large surface as it has been blitted onto the smaller one as before. We can move this coordinate a little bit in order to see the whole thing without overlapping anything. We'll need a little bit more space to do that. There we can see the size of the 400 by 400 large blue surface independent of overlapping the other ones. The last thing that we're going to do is we're going to make another surface and call it cursor. It's going to be small. It's going to be 15 by 15. And we're going to fill it with orange. We're going to turn off the visibility of the mouse by setting the Boolean value in the Pygame mouse.mouse.setVisible to false. So we do not see the operating system's mouse, the white familiar arrow. Also at the top of the screen, we're going to get the mouse position. And the mouse position will be found by assigning to the variable mouse underscore position a call to the function pygame.mouse.get underscore posts. Mouse position is now a coordinate of the mouse. And we're going to use that mouse position as the blit location of that small surface that we called surface underscore cursor. So the screen is going to receive surface underscore cursor at the mouse position. Let's see the effect. We have a square, a small square of color, and I can move it around. It's the mouse cursor now. The layering is important. We can see that the mouse cursor gets hidden if it is intersecting the locations of the surfaces that have been blitted to the screen. And the reason why it appears to be hidden is because it's blitted first, and then the other things are blitted on top of it. Again, the order in which we blit is very important. If we take this mouse cursor graphic and we put it into the middle of this list of things that we're blitting, and we moved it around, we could see that it's on top of surfaces that have been blitted before it, but still underneath surfaces that have been blitted after. And of course, if we want the mouse cursor to be on top of everything, then we want to blit it last or very late in the composition of the screen. There it is, the last thing that's blitted, and it appears to be on top of everything as I move it around. Now you have seen how surfaces, additional rectangles of color completely under your control, can be used to create and manage some fundamental effects. Make a simple program in which you create 4 surfaces, each filled with a different color. Arrange them on the screen surface so that they do not overlap, much like the quadrants of the coordinate plane in algebra. Allow the primary display, the screen surface, to be seen as a border around the 4 others and a little in between them. In other words, do something similar to what we've done here. But rather than this haphazard display, make your surfaces not overlap, but have a little bit of a border around it of the primary surface, which in this case is black, peeking through. Have fun.